Hey guys, welcome back. We are still working on 6.2 orthogonal sets, and we're now skipping example number 8 and going into example number 9. I do want to encourage you guys that you can look at example number 8 because the equation that we're going to use for this is that c sub n is equal to y dot u sub n over u sub n dot u sub n. And so if you look at the work that I did for example number 8, you will get this equation for each individual values of c sub 1, c sub 2, c sub 3. C sub 1, 2, 3 is just going to be the scalars of those matrices. And so I'm going to go ahead up here and write down that we have a u sub 1, a u sub 2, a u sub 3. If we had another column, then we would have a c plus 4, c4, u sub 4 here. So the question says to express y as a 3, 7, 4 matrix as a linear combination. So again, friends, because it says a linear combination, the answer that we want is going to be in the form of y equals this combination. And it tells us that these are orthogonal bases, right? So it tells us that the dot products of each one of these is going to end up being 0. So if I dot u1 with u2, it's 0, u2 dot u3 is 0, u1 dot 3 is also 0. So we've proven that in the last video, how to show that these are orthogonal bases. It's telling us they're orthogonal, and now it's asking us to express y as a linear combination with these orthogonal bases. So in example number 8, you see the work for this equation, but it's pretty straightforward for us to go ahead and plug stuff in. So what we're going to do is we're going to find c sub 1 first, and it's a little tedious, but it's okay. So we're going to dot y with our u sub 1, and then we're going to also dot u sub 1 with itself. So let's do that. So if I ask you guys to dot y with u sub 1 in this entire lesson, that's all we've been doing is doing the dot product, right? So this is not challenging at all. We're going to take the first component of y, which is 3, and we're going to multiply it by the first component of 1 in u sub 1, which is 1. And then we're going to take 7 and multiply by that negative 1. And then we're going to take 4 and multiply that times 0. So again, we're just dot producting y with our u sub 1 here. And when we do this, we get 3 minus 7 plus 0 gives us a negative 4. So the numerator for c sub 1 is actually going to be a negative 4. Again, we're just looking for the scalar value of this. Then we're going to dot itself. So u sub 1 dot itself. So we're going to come back over here to u sub 1, and we're just going to go ahead and dot it with itself. So our first component is multiplied together. So we basically essentially square these numbers. So 1 times 1, negative 1 times negative 1, and then 0 times 0. So we're always going to get positive numbers here, right? So this will not ever be 0, just because it can't be. It's a denominator, and these are always going to be in positive numbers. So we get 1 plus 1 plus 0 gives you a 2. So we get a value of negative 2. So then we can already assume that when we do our problem here, we're going to get that c sub 1 is actually going to be equal to negative 2. And that's all we have to do, guys. So we just have to do this 2 more times, where we now look at c sub 2. Well, c sub 2 is going to be, again, y, because, again, this is what we're expressing as, right? Y is expressed as a linear combination. And then we're going to dot that with u sub 2, and then we're going to do u sub 2 dot it with itself. So y dot it with u sub 2. Again, we're going to take the y component, and we're going to now dot it with the second column, right? So our u sub 2 values. So we're going to do times 1. We're going to do 7 times positive 1 again, and then we're going to do 4 times 0. And sorry, that's be equal to. Actually, let me change that. Get rid of that. That's like not equals to. We want to make sure it's equals to. And we get that this ends up being 3 plus 7, which is 10. So our numerator for c sub 2 is going to be 10. And when we dot u sub 2 with itself, and you guys are very intelligent people here, so you guys know what I'm going to do here now. So we're going to get 1 times 1, and then we're going to do 1 times 1 again. So again, just dotting u2 with itself, and then 0, 0, and we're going to get, again, 2. So we're going to go ahead and get that subscript, or c sub 2 is equal to 5. So that means that our value here is going to be 5. All right, so let's look at our last one. So c sub 3 is going to be y times c sub 3 all over c sub 3 with c sub 3. And so I'm assuming here, guys, you pretty feel comfortable with all of the work that we're going to do with this problem. So when you do this one, and you can verify it yourself, that the numerator, when you dot y over here, and by the way, it's easy. Look, 3 times 0, 7 times 0, and then 1 times 4, or sorry, 4 times 1, right? So it's going to be 4. And then when you go ahead and do c sub 3 with itself, you're going to get 0, 0, and 0, 1. And so you get the fact that this ends up being 4. So our final answer for this question is that y, let me change my color one more time. Let's get a different color. You guys, how much I like my different colors here. Okay. So our final answer here is y is going to be equal to, all right, our c sub 1 value is going to be -2, and then u sub 1 plus 5 u sub 2, and then 4 u sub 3. Ooh, sorry, that was not a good u. Still not a good u. Oh, wow. Okay. All right, u sub 3. Oh my god, I wrote c again. What is wrong with me? I'm sorry, guys. If I write c again, I'm going to be really mad at myself. All right, u sub 3. Okay, there we go. Oh, we finally got it here. All right, so that is our way to do the problem. Okay, so there actually is, before I leave you guys, there actually is a way that we have done this before that is a little bit shorter. So that is a way that we do things, but you guys know with linear algebra, my goodness, everything we do, it's always, there's a different way to do the problem. If we actually, side note it for 1 second here, if we actually took this matrix, and let's call this matrix A, I'm sorry. So if we make H matrix A, and we're going to use the dimensions of our bases, so 1, -1, and 0, 1, 1, 0, and then 0, 0, 1, and we augment this with our y value. If we augment it with our y values, right, and then we row reduce, guess what we're going to get? You guessed it. We're going to get 1, 0, 0, wait for it, -2, 0, 1, 0, +5, 0, 0, 1, 4. So this is how you're going to check that you got the right answers for this. And this is going to give you your C1, your C2, or your C3. And how we've defined this before is this is the solution to this, where we give it to you guys as a system of linear equations. But here we're not doing that. So this is a check to verify that you actually got the values themselves of -2, +5, and 4. Cool, right? All right, guys, that's it for this video. I got one more for you. So have a good one, and I'll see you in the next video. Take care.